Welcome to Pre-Calculus. Today we will investigate how to graph sine and cosine, where we see some kind of translation and phase shift. We'll take a look at two examples. Our first example is this trigonometric function y equals 2 cosine of 2 theta plus 2. So we want to start off just by graphing this function. And one thing we need to note is that we do in fact have a change here, and what's been changed for us is the this one has been translated 2 up, so that's that plus 2 at the end. I also see that we've got some change in the period. We got that 2 there by the theta, and then also our amplitude has been changed by that 2 in the front. Just to line that up again with our general form, we would say that this is A times cosine of B times theta plus, in fact, we'll call that minus C, and then plus D. So the parts that we're seeing here, we've got the A, so that's our amplitude change. In fact, we can go ahead and say what our amplitude is. Amplitude for this function is going to be 2. So we'll just write that here because I see I've got to make that analysis at the end anyhow. So 2 should be our amplitude. Again, that's the height of the wave. We should see that it's increased from 1 to 2. I've also got this B, and that's what we would call some kind of period change. And remember how we change the period is we take the usual period of a function. So for cosine, the usual period is 2 pi. And you divide it by that B value. So for us, we're going to take 2 pi and divide it by our B value of 2. So the period that we'd expect for this function is shorter than the normal one. So half of it's going to be more compressed horizontally. I do not have a minus C. That's just not in this function, but I do have a plus 2, that plus D, and that is going to be a vertical translation. So the whole function has been lifted up 2 units. So that's kind of our initial analysis, and we can kind of predict what the graph should look like. It'll be taller than cosine normally is because the amplitude has been enlarged. It'll be, in a way, narrower, more frequent waves because the period's been decreased from 2 pi to pi, and the whole graph should be shifted up too. So let's follow that initial analysis by graphing the function. So what I'd like to do is keep in view our unit circle. That's really how we define our trig functions. So there's our unit circle. What I want to do is start creating a table. And let's just put our theta and our y value. And I see for this graph, we kind of have from negative pi to pi. So that's kind of be how we'll deal with this. So negative pi. Let's see what we've got. So I'm just going to put the ones that are marked here. Negative pi over 2, 0, pi over 2, and pi. So let's try to calculate some of these outputs. So I'm just going to take the function and let's plug in our theta value. So it's 2 times cosine of 2 times negative pi. So that's our first value we're plugging in here. Then we'll pick up with parentheses plus 2. So that's what we need to calculate. So let's just start with the angle cosine at negative 2 pi. So that's going to be, let's shift over here to our unit circle, equivalent to 2 pi. So cosine at 2 pi is going to be the x value here in the yellow. So that's 1. So 2 times 1 plus 2, that's going to give us a value here of 4. So at negative pi, the value is 4. Let's go ahead and calculate at negative pi over 2. We may have to do some intermediate ones, but let's see. So we'll take the time to just write it out first. So it's 2 cosine 2 times, now our angle is negative pi over 2. Close the parentheses plus 2. So again, I'm going to start here at the angle part, the 2 times negative pi over 2. So that's going to multiply to negative pi, which is the same as positive pi. Cosine value there is negative 1. So this is going to be 2 times negative 1 plus 2. That's negative 2 plus 2. Overall value of the function is 0. So I think probably if we were to include an intervening value here between negative pi and negative pi over 2, that'd be negative 3 pi over 4. Let's see if that comes out to 2. I see that the output might be halfway between 4 and 0. So let's see if that is the case. 2 cosine 2 times negative 3 pi over 4 plus 2. So again, my attention goes to that angle first. See, I forgot my pi there. So 2 times negative 3 pi over 4 is going to be negative 3 pi over 2. And that's going to be in the negative direction. So it's really going to land us at pi over 2 or 90 degrees. Value there is 0. So it's going to be 2 times 0 plus 2. 2 times 0 is 0, plus 2 is 2. So in fact, yeah, that's a nice pattern there. So my feeling is that for negative pi, that either increases back up to 2 or would go down below 0, maybe to negative 2. Let's try that one. I'm going to kind of clean up my table here. I got some extra values. Okay, so let's plug in now 2 cosine 2 times negative pi over 4, close parentheses, plus 2. So again, I want to look at the angle. 2 times negative pi over 4 is negative pi over 2. So we're going to go in the negative direction. And that's going to give us down here at 3 pi over 2. So the value there again is 0. 2 times 0 is 0 plus 2 is 2. So I see a pattern forming here. We went 4 to 2 to 0 up to 2. My feeling is that the value at 0 again is going to be 4. Let's confirm that, and then we can use the pattern to give values for the other domain pi over 2 and pi that we got here. So I'm just going to plug in 0. That's awfully easy to calculate. My angle there is 2 times 0 is 0. So that's at standard position, which has the cosine value of 1, my yellow x value there. So 2 times 1 plus 2 is in fact 4. So now we got a pattern going on. We can drop the calculations and just fill in with our pattern. So at pi over 4, our value is going to decrease from 4 to 2. Pi over 2 is 0. 3 pi over 4 is back up to 2, and then pi itself is back up to 4. So you do have to do a little work initially to catch the pattern. Once you catch the pattern, you just use it to kind of extend. Let's graph. So at negative pi, it's at 4. At 3 pi over 4, so that's that middle one here, that's at 2. At negative pi over 2, it's 0. And I can really see the pattern here on the graph. At negative pi over 4, 2, 0 is 4. Back down to 2 to 0 to 2 to 4 to 2. We could just keep going forever. And I see my curve pretty clearly here. So as I'm sketching this in, I just need to kind of be mindful. Did I have an amplitude change from 1 to 2? Definitely. This is a taller graph. In fact, let's go ahead and mark our amplitude on the graph. So that's from the middle line up to the crest of the wave. Definitely my amplitude there is 2. See, that's 2 units. My period, has it changed from 2 pi to pi over to just pi? Well, I see I got a full cycle here from negative pi to 0, and then from 0 to pi. Definitely that's my period. You can see a vertical translation as well. The central line is typically at the x-axis. That whole line has been shifted up to, along with the rest of the graph. So that completes that first example where we've got an amplitude, period, and vertical translation change. Let's take a look at a second example. So here we've got the function y equals 1/2 times sine of theta plus 4 pi over 3. Let's do our initial analysis. So I'm just going to overlay that template again. So y equals a, this one's the sine function, times b theta minus c plus d. So the parts that I've got here, I do have a change in my amplitude. It's gone from 1 to 1/2. So very different from our previous example. That one stretched out because the amplitude had been enlarged to 2. This one, our amplitude is going to be half the height. It's going to be a very much shorter curve. I don't have a b value. There's nothing in front of theta. I do have a minus c plus 4 pi over 3. And that is a phase shift. Something we didn't see a whole lot in the previous example. And I do not have a vertical shift. So I've got different kind of transformations occurring here. Let's graph this one. So again, what I'll do is I'll start to create a table. And one thing I'm noticing with this one is that I've definitely got plus 4 pi over 3. That is a tricky fraction to add and subtract. So what we can do is I'm just going to follow the lead of the x-axis here. I'm just going to write the values on my x-axis. So negative 3 pi over 2. I'll leave a little space just in case I need to come back, but then I'm going to write negative pi. So I'm just going to mark the ones that are here. Negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. So I'm taking a little different approach because of that 4 pi over 3. That's very, very fractiony. Just to get us feeling about what that's going to do to our function. Typically, what we would do to talk about the phase shift is I would say that the normal phase or period of this function is the sine function. So it would typically be from 0 to 2 pi. So if I just took those extremes and just said, okay, normally my angle's in between those, but my angle involves plus 4 pi over 3. So a lot of times the way that we kind of predict the phase shift and how it changes the starting and ending point of the curve for one period is you just subtract or add that value. We'll also subtract and add it from these extremes. So what I'm going to see is I should have a lower starting value of negative 4 pi over 3. And then I'm going to have a ending value of 2 pi, which I'm going to call 6 pi over 3 minus 4 pi over 3. That's going to go 2 pi over 3. Well, I don't even have those marked on my x-axis, and it's hard to place them. So I'm going to keep that in view. We'll try to kind of locate negative 4 pi over 3 and 2 pi over 3 on the graph when we go to Desmos. But what I want to do is I just want to kind of respond to what I've got here in terms of the given domain. And we'll graph our function kind of using that. So I'm just going to, again, record that down. And let's go to Desmos. So a little different on this one. I'm not going to unit circle directly. I'm going to lean on the calculator. So we'll just start by inputting the function. So just to make it friendly for making a table, I'm going to call it f of x instead of y equals, so we'll put our half sine function. Instead of theta, I'm going to use the independent variable x and then plus 4 pi divided by 3. So I just want to mark those beginning and ending spots. So it's y equals, I'm sorry, those are x values. So x equals negative 4 pi over 3. Pardon me, I'm getting it set up. So x equals negative 4 pi divided by 3. So that you can see that's where it's starting. It's a little past negative 4. And then from our calculations, the ending point should be 2 pi over 3. And we can see real clearly that catches a full period of the sine function. So like our algebra work is on point there. We just need to get some table values for between those two places. So I'm going to pick up the table. And so here I've got to kind of go back to where my graph was. So I see the x values here. They're just rectangular, -1, -0, 1, 2, -2. I need those to be in radians. So first one I'm going to type is -3 pi divided by 2. I can start to see these points popping up on my graph. So I had the negative pi. The next value I had, so again, these are just the values that I picked up from my x-axis on my graph on the notes. So negative pi over 2. We did have 0. That was there. And then let's do pi over 2 and 3 pi over 2. So that's somewhat helpful. I kind of got values in there. I think I forgot one here. Let's put in pi. And really, that's probably good for us. Let me go ahead and record that down. I can kind of see these points appearing here on the curve on Desmos. What I am missing are the extreme maxima and minima, but I think we're okay. So I'm just going to mark down -3 pi over 2 is -1/4. Negative pi is an approximation 0.43. And then I got +1/4 at negative pi over 2. 0 is negative 0.43. Pi over 2 is -1/4. Pi is positive 0.43. And 3 pi over 2, 0.25. And I'm just going to mark here that our function pretty much begins at -4, a little past it to the left, and then it terminates there on the right at 2, a little past 2. So I can see the challenge of that phase shift plus 4 pi over 3. It really throws off where our graph is situated, but we can work around it with the tools that are at hand. So I'm going to head back to the notes just to sketch this one. And what we'll do is, again, I'm going to fill in this table with the values we just got from the calculator. So it's going to be a real recognizable pattern. So it's -1/4, positive 0.43, 1/4, negative 0.43, -1/4, positive 0.43. So you can see the pattern is very regular once we have it written. All right, so let's graph those points. So I'm going to start here at -3 pi over 2. It's -1/4. Negative pi is at 0.43. Negative pi over 2 is at +1/4. 0 is -0.43. Pi over 2 is at -1/4. Pi is at 0.43. And 3 pi over 2 is at 1/4. So just kind of filling in what we've got here, I'm going to sketch the curve. So I'll start here at 3 pi over 2. So definitely the curve's going to climb up, reach a maximum and start climbing down, reach a minimum, start climbing back up, reach a max, start climbing back down. Let me re-sketch that because that middle of that curve got a little distorted. So definitely we've been able to work around that kind of strange phase shift. Again, if I were to try to mark it, it's at -4 and 2. So I wonder if we even have, yeah, -4 should be roughly here. In fact, what I can do is just mark on my graph where it's hitting the x-axis. So it's roughly here. And what I would say that's at about -4. Exactly, if I'm going to write it, that's -4 pi over 3. And if I trace a full cycle there, that far on the far right's my 2 pi over 3. So I'm just going to mark those extremes from our phase shift. Since that was the challenge on this one, we had to do a lot to work around that. But we did it. Well, thank you for joining for these 2 examples of graphing trigonometric functions involving some kind of phase shift or vertical translation. See you soon.